The ore body is the first important component. What have you got to work with? How much strip ratio do you have? How much waste do you have to move? Then you look at the magnetite recovery. How much magnetite do you get for every ton of ore that you feed into the plant? And then finally, what is the vanadium grade of that magnetite? So Gabonintha has a really good combination of those things. Looking at how to process it from there, we can actually produce a final product that can be marketed in the US, in Europe, and even back into China. I started working on the vanadium battery over 20 years ago, so that the technology was under development, under discussion, and it just didn't seem like it was going to go anywhere. But today, with the new green energy policies around the world needs a vanadium battery. Over years, China has been slow to adopt microalloyed steels in their rebar and their construction materials. They use, historically they used about a quarter amount of vanadium per ton of steel produced in the country that North America would produce. They've now grown to about 50% of that, and they continue to grow. As these new rebar standards are fully adopted, they'll grow even further and eventually approach the North American standard. And in that, the demand for vanadium will grow astronomically. There's a need for new projects to come online now, and they'll continue to be that way. Capital cost of Gabonintha is consistent with the initial capital cost that was made at Largo, for instance, or Winnemura, or the projects in South Africa. The number that we've developed with our team is consistent with a vanadium project of this magnitude. No one wants to invest the level of money that's required for a project if you're not going to have billions of dollars return, and this project does it.